Okay, here's some notes for lesson 7.3. Okay, the first thing is perpendicular lines. Make sure that you know perpendicular lines are lines that intersect to form right angles. Okay, typically you'll see this symbol instead of them writing out A is perpendicular to B. Okay, they'll put this symbol there. This is what perpendicular lines look like. Okay, you have a right angle there. That tells you that those are perpendicular lines. Okay, the next thing is the perpendicular transversal theorem. Okay, I'm going to read it first and then I'll explain it. It says, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, so here's what that means. These blue lines on my page, okay, those are parallel. They don't ever meet. Okay, these are my two parallel lines. If a transversal, okay, a line that goes through them, is perpendicular to one of them, then it has to be perpendicular to the other. Okay, these have the same slope. They're running in the same direction. So if I draw a transversal that's perpendicular to one of them, it's perpendicular to both of them. Okay, and we'll see an example of that in our 7.3 practice in just a second. The last thing I want to go over is a perpendicular bisector. Okay, you know what these two words mean individually. Perpendicular means they form a right angle. Okay, and a bisect means cut in half. So if it's a perpendicular bisector, it's cutting something in half. Okay, it's intersecting at its midpoint. And because it's perpendicular, it forms right angles. Okay, so let's look at the 7.3 practice problems here. In the diagram, L is parallel to M. That's what that symbol means, parallel. The measure of angle 1 is 90. Okay, so this is 90 degrees, which means it's a right angle. And angle 5, right here, is a right angle. So that one's also 90 degrees. Okay, and then we're going to use the diagram for 9 through 11. The first one, number 9, says, explain how you know that L is perpendicular to P. Okay, how do I know that L is perpendicular to P? Well, L is here. Okay, P is here. It told me that angle 1 was 90 degrees, which means it's a right angle, and that is why L and P are perpendicular, okay, because they form a right angle here. All right, the next one says, show that the measure of angle 4 is 90 degrees. Okay, how do I know that this is 90 degrees? Well, if we go back to our perpendicular transversal theorem, I know that if I have parallel lines, okay, which L and M are parallel, and one of them, okay, we already said L was perpendicular to P, okay, because this transversal is perpendicular to this line, L, and L is parallel to M, I know that M is also perpendicular to P. Okay, because M is perpendicular to P, that means that all of these are right angles. And that's how I know the measure of angle 4 is 90 degrees. Okay, the next one, make use of structure. Show that L is parallel to N. Okay, same reason here. It told me that angle 5 is a right angle, and I knew that angle 1 was 90. Okay, angle 1 is 90 degrees, which is a right angle. Angle 5 is a right angle, which is 90 degrees. If you think back to the lesson 7.1, I have corresponding angles here, 1 and 5. Okay, they're in the same position in their group of intersecting angles. So 1 and 5 are corresponding, meaning they are congruent. Okay, that's why they're parallel. I have corresponding angles that are congruent. This is the right angle, this is the right angle. So that tells me that L and N are parallel. Okay, for number 12, the perpendicular bisector of CD intersects CD at point P. If CP is 12, what is CD? Okay, let me draw a picture for this. Okay, the perpendicular bisector of CD. So I'm going to draw CD. Draw a perpendicular bisector. Okay, it needs to be a right angle. It's a right angle here, and it's a bisector, so it needs to be in the middle. These two pieces need to be equal. Okay, it says it intersects at point P, so here's point P here. It says if CP is 12, okay, well here's CP. If that's 12, then what is CD? Okay, that's what I'm trying to find. Well, if this is a perpendicular bisector, then this is in the middle. So if this half is 12, this half is 12. Okay, and if it's asking me for the whole thing, well, how do I find what the whole thing is, what CD is? All I have to do is add these two together. So CD is 24. All right, the last part is number 13. An angle formed by the intersection of two lines is obtuse. Could the lines be perpendicular? And explain. Okay, if an angle formed is obtuse, okay, obtuse angles are bigger than 90 degrees. So can the lines be perpendicular? No. The angles formed by the line cannot be obtuse or acute. Okay, they need to be right angles. That's the only way that it can be perpendicular.